training over long periods of time actually causes adaptations. In fact, let me write that down. Training, and we are talking about training over time, by the way. Training over time, so I guess we're talking about weeks, months, years here. Over time causes adaptations, all right? So this is an interesting word for us. Now, let's just quickly stress what we mean by an adaptation, okay? An adaptation is a long-term physiological change to the body. So therefore, the question I want to pose today, how do we structure our training to cause the right type and the most adaptations possible? Now, in order to achieve that, I've got my little sort of rectangle tool here. I'm going to make a rectangle. So let's make it nice and big like this, okay? So I've made myself a rectangle. Great. Where am I going with this? Well, the first thing I want to do is in fact, let me sort of switch to line drawing. In fact, no, I won't do it that way. I'll do it with the ruler. Let's bring the ruler in here. I reckon that my I'm trying to get 90 degrees. I reckon that halfway across my line is somewhere there. Okay, so let's break our line in half. So let's break our box in half. So something like that. Where am I going with this? Well, let's break it a little bit more here. All right, I'm going to tell you, or I'm going to claim, I don't know how well I've sketched this, but I'm going to claim that area there, okay, this area here, which I'm actually going to fill in as a little kind of pink area, this area here, all right, I'm going to claim that area there is what I'm going to refer to as the fat burning zone. Fat burning sounds serious, doesn't it? Fat burning. And I want you to be clear that this is from 50 to 60%, 50 to 60% of what we refer to as max heart rate. Okay, so max heart rate. So this whole area represents heart rate, and max heart rate would be this line here, right at the end, the maximum up here. Okay. Now, what I also want to sort of stress to you, therefore, is that from 0 to 50% up here, we consider this to be sort of non-active. Okay, so just be aware here. We're considering this to be non-active, or stationary, sedentary, I suppose, non-active. Your heart rate is not at 0 when you're not active. It's, it ticks along at something under half its highest rhythm, right? Generally speaking. But between 50 and 60% of maximum heart rate, if we undertake activity like walking, very gentle jogging, it could even be things like gardening, mowing the lawn, washing a car. This is the fat burning zone. Now, let me bring my ruler back in. I'm going to give you another zone here, and I'm going to give you the zone where I'm only estimating. I'm going to say that this zone here now, let me go to about there. I don't know how well I've done my sort of proportions, but never mind. I'm going to say that this zone here, okay, that zone there, I'm going to refer to that, and we'll fill it in. Hopefully it's going to fill in correctly. So I'm going to refer to this as our aerobic zone, okay? So this is our aerobic zone. Aerobic zone. And to be clear, it's from 60 to 80% of what? Maximum heart rate. Okay, so this is our aerobic zone. Now, I will say in other qualifications, sometimes this number gets stretched to 85%, but I'm just letting you know that that's where here we're talking about 60 to 80%. Now, what does it mean, the aerobic zone? It means that between 60 and 80% of maximum heart rate, we will be we will be achieving certain aerobic adaptations. Okay, we will be, for example, developing capillaries around the alveoli and at the muscle, for example, these kind of aerobic adaptations that take place. Now, I haven't done this very well because I don't think I've left myself 20% by any stretch of the imagination. It's actually gone really quite badly. But the point I would make here, it went really badly actually, but the point I would make here is that this line here, if we were to sort of fill that out as orange, we could say that was 80 to 90%. If I'd drawn it better, it would be even better, of course. So this is like 80 to 90%. And what we're saying here is that this is the anaerobic zone. Now, again, you might be wondering, well, what about the 90 to 100% part of this? Well, yes, that would also be anaerobic. The point we'd probably make here is it's actually quite hard to get into this zone and to maintain that zone, okay? But yes, it's anaerobic if you want to think about it that way. But 80 to 90% we consider to be the anaerobic zone, okay? So in that zone, we are working and we are developing anaerobic adaptations. Now, what I want to do here is let me drag you down. I actually want to do a little bit of calculation here. I want to give you an example of what I'm going to call case 1. And we're going to do some calculations of heart rate zones. In fact, let's write over here. Let's put it in already. We're also going to have a case 2, which is going to be over here in a few moments' time. Now, case 1, let me tell you what case 1 is. Case 1 is a 16-year-old, and I'm sort of wondering whether this might describe you. Maybe you're 16, maybe you're 15, maybe you're 14, I don't know. 16-year-old GCSE PE student. So I'm kind of imagining this might be you or similar to you, okay? So a 16-year-old GCSE PE student. And what I want to sort of say here is we can calculate your maximum heart rate. We know maximum heart rate is calculated by 220 minus age. Someone in my group recently actually asked me, well, why is it 220? And I said to them, well, look, I don't know the actual exact reason, but the point is that our kind of biology, our human biology, leads that to be like the upper limit of how fast the heart will go. Okay, so if you look at other mammals, for example, that have a single loop circulatory system, they can beat much faster, as they do with certain birds, for example. But the human upper limit seems to be this one. But anyway, maximum heart rate, in fact, let's be clear about that. Max heart rate equals, for this person, 220 minus age. So therefore, it's 220 minus 16. So therefore, it is, in fact, 204 beats per minute. So we know that max heart rate for this person is 204 beats per minute. Now, what I want to do is I want to find out what we would refer to as the aerobic zone. So let's see if we can find the aerobic zone for this performer. We know from what we just looked at, the aerobic zone is between 60% of max heart rate and 80%. So how do we go about judging that? And I'm pretty sure you won't be asked to calculate it, but I just want to sort of prove to you that you actually can calculate it. So let's just do this. So let's first of all, let's do the let's do the upper threshold. So let's do the 80% threshold. So I want to take our maximum heart rate, which is 204, and I want to multiply it by 80%, which we can do by 0.8. Okay, so therefore the upper limit for this performer, let's just go back here, the upper limit here is 0.8 times 204, that maximum heart rate, gives us an upper reading of 163 beats per minute. So when this person's performing, they should be aiming for that upper limit to be 163, no more, or there or thereabouts. Now, if we look for the lower limit, which of course is going to be maximum heart rate, multiplied by 0.6 or 60%, that's going to give us 122 rounded, okay? So if I go to 0.6 times 204, this gives us, what was it again? It gives us, was it 122? Have I misremembered that? Yeah, 122. So it gives us 122 beats per minute, okay? So 122 beats per minute. And the point I want to make here is that our performer, our 16-year-old GCSE student, if they want to work aerobically, should be working in that zone, okay? Now let's look at case 2. Who am I thinking about here? I'm thinking about a 43-year-old website owner. Who could it be? 43-year-old website owner. So this is my other case. So let's just go through the calculation for maximum heart rate. We've got 220 minus the age, which is 43, which gives us a maximum heart rate of 177 beats per minute is this person's maximum heart rate theoretically. Now, we could use other principles to calculate that, but for now, that's fine. Now, what I want to do again is I want to find the aerobic zone. So I want to do 0.8 times 177, and also 0.6 times 177, and that's going to give us our upper and lower aerobic thresholds, okay? So with this one, let's do 177 times 0.8, 80%. Okay, so we've got 142 rounded. 142 beats per minute is the upper limit. And if we bring the calculator back, clear 177 times 0.6, we have got here 106 beats per minute as the lower limit. And the point I'm trying to make here is that unlike the 16-year-old GCSE student, this person here, this 43-year-old, should be aiming in this aerobic zone. Why? Because in both cases, guys, that will put both participants, can't get my scroll bar to work, unfortunately. It really isn't working. Let me try on here. Okay, so in both cases, that's going to put both these performers bang in this zone here. Now again, we could calculate the same thing, 80 to 90%, to find the anaerobic zones. That's absolutely fine. But we just here looked at aerobic examples, and that's exactly how we calculate training intensity in this case.